Measure airflow with the HVAC temperature rise formula to get accurate cubic feet per minute readings that reveal whether your system is delivering the airflow needed for comfort and efficiency. To calculate airflow using the temperature rise method, first measure the supply air temperature and the return air temperature with reliable digital thermometers located close to the register and return grille. Subtract return from supply to get the temperature rise in degrees Fahrenheit, then use the system's sensible heat formula. Airflow in cubic feet per minute equals the system's sensible heat in British thermal units per hour divided by 1.02 multiplied by the temperature rise, where sensible heat equals the cooling or heating load in British thermal units per hour. If you do not know the load, measure electrical input and use manufacturer data or a properly sized calorimeter. Always account for fan calibration and static pressure, because inaccurate fan curves distort CFM estimates. When measuring, ensure registers are fully open, duct boots are not collapsed, and measure at multiple supply registers to find distribution imbalances. Balance readings by comparing measured register CFM to design CFM per room and adjust dampers incrementally. Rechecking temperature rise after each change. Use a manometer to record total external static pressure at the blower with the system running, and subtract external from total to isolate internal pressure losses. Any reading above the manufacturer's recommended static pressure indicates likely duct restrictions or a mismatched blower. For repeatable accuracy, average at least 3 temperature readings over a minute at each point to reduce error from momentary fluctuations, and log ambient conditions because wet bulb and dry bulb humidity affect sensible heat calculations in cooling mode. Replace or weigh filters before and after test to quantify pressure drop attributable to the filter. A high initial pressure drop suggests wrong filter media or excessive thickness for the system. If you suspect return restriction, temporarily remove the HVAC filter and measure the change in static pressure and CFM RO. Note that this is diagnostic only and run only briefly to avoid system damage. Use a pitot tube or calibrated capture hood for spot verification when accessible. Cross-check hood-derived CFM against temperature rise-derived CFM to validate your methodology. Document every measurement, time of day, and blower speed setting so future troubleshooting can compare apples to apples. One of the biggest problems is blocked or undersized return grilles, causing low return air and negative pressure, which leads to reduced supply CFM and poor temperature rise balance. Fix it by measuring return grill free area, replacing with larger grill or adding dedicated return ducts, and sealing around the grill to prevent bypass. One of the most common issues is crushed or kinked ducts, creating severe airflow restrictions and turbulence that show up as high static pressure and low CFM. Correct this by physically inspecting accessible runs, repairing or replacing collapsed flexible duct with smooth inner liner or short rigid transitions, and supporting ducts so they maintain shape. One of the frequent maintenance oversights is dirty filters and register blockages that incrementally choke airflow and skew temperature rise reading. Solve this by using correctly rated filters that match manufacturer resistance limits, installing filter gauges to monitor pressure drop, cleaning or enlarging register paths, and instituting a scheduled replacement cadence. BigHomeProjects.com lists local HVAC pros and vetted contractors so homeowners can find service technicians who know how to perform precise temperature rise airflow testing and duct diagnostics. The directory also helps contractors get work by connecting them with homeowners actively searching for airflow testing, duct repair, and system balancing services.